this will actually be unit 7. Um, and this unit is on exponent, so you're going to have a whole lot of different rules that will be covered in this particular unit. And also, if you notice on the front of your calendar, okay, besides exponents, we're going to also be doing, there are 2 different tests in this unit, actually 3 if you count your midterm, but you'll have an exponent test here, and then you'll have a radicals test at the end, and your midterm is in between. So your midterm exam will be on 2/14 and 2/15. So if you're A day, February 14th, if you're B day, February the 15th. Okay. There are a couple of handouts in here, but besides that, you'll be doing some additional handouts besides what's in the packet to help you prepare for the midterm. But I would suggest preparing now by going back and looking at your old tests. So you were supposed to keep all of your tests from each unit. So I would suggest taking those tests and start from unit 1 and start looking at those topics. Okay, you could also go on to Blackboard because all of my lessons are still there, and maybe look at at least a test review if you have lost your packet, to make sure you know how to do those types of problems in each one of the units. Okay. All right, so we're going to go ahead and start the foldable. So this is the first thing we're going to do, is fill out a foldable for our notes. There are 2 different rules we're going to be going over today. One is called the product property, and the other one is called the quotient property. So obviously product means that you are multiplying, so that's why you see the dot there. Quotient means you're dividing, so that's why you see that line there for division. So if you want to fold this, you would just fold it where you could still see the title that says properties of exponents. So this entire unit, again, we're going to be talking about different properties for exponents. Okay. And then after we take the exponent test, we'll be talking about simplifying radical expressions. All right. So you do have quite a bit going on in this particular unit. All right. So let's complete the foldable first. So looking at the very first property, which is called the product property, and right here you'll see where it says if you have the same base, so these numbers here, that's called your base, and obviously the smaller number at the top of the base is called the exponent. So this is saying when you're multiplying, so when you see a dot, you're going to take the same base, A, and you're going to add the exponents together. Okay, so let's just take some concrete numbers here. And then we're going to, so here again, you just have the rule here. You have base A, you have a number here, you add them together. So an example would be same bases. So I have the base X, I add 2 plus 3, that'll give me X to the 5th power. It's very, it's a properties are just like rules that you follow, and it's very easy. So all you do is add the exponents together if they have the same base. Now I'm going to show you why this works. That means, why do you add them together? Because we know X to the 2nd means X times X. We know X to the 3rd means X times X times X. So how many X's do you have? You have 5. So if you expand it out, you can see why the property actually works. So that's why it works. All right, so let's move on to here. So here's example 1. So we have X to the 4th, X to the 3rd. We have the same bases. We add them together. We get X to the, and this would actually be X to the 7th. Okay, I think this gave me the same example. Okay, so just change that to a 7. Okay. All right. Example 2. Okay, I think something got kind of messed up over here. Let me just move this out the way. So we have a to the second, a to the fifth. What is this exponent? 1. So how many, what would I have? What's 5 plus 2 plus 1? All right, a to the 8th. Okay, and this is just showing you applying the rule. This is not for this particular property. Okay, so this is the property that you're using. This is the rule that you're using. All right, number 3. Okay, like I said, it's very straightforward. So again, you take your bases. Obviously, you're going to add 3 plus 5. But what do you do with these numbers in front? Okay, well, it's multiplication. So what do you think you should do to them? You should multiply them. So 2 times -6 is going to give you what? -12. You add your like bases together. You get -12 and then m to the 8th power. All right, any questions so far? Okay, it's pretty straightforward. All right, next one. So again, we have these numbers in front of the g's, so we can multiply 4 times 3, and then we're going to add the like bases here. 4 plus 9, what's 4 plus 9? And then plus 3. So we're going to have 12g to the 16th. All right, 12g to the 16th. All right, so you go ahead and do 5 and 6. I'll give you a second to get those done. All right, so we're going to multiply 3 times 7. We know that's 21. And then our y's to our y's, that'll give us 6. Our z's to our z's, that will give us 9. So we have 21, y to the 6th, z to the 9th. Okay. And then for number 6, we're going to multiply the 8 times the 5. We're going to add our a's, add our b's, and add our c's. So you should have 40, a to the 11th, b to the 8th, and c to the 4th. All right, so we call that the product property. So keep in mind, when there's not an exponent, the invisible exponent is 1. Okay, the invisible exponent is 1. Every number and every variable technically has an exponent. Okay, so when it's invisible, it's 1. All right, so we're going to move on to the quotient property. So it's just the opposite of multiplication. So we added the exponents together when we were just multiplying. So now for division, we're going to subtract the exponents. So when you have one exponent at the top, one at the bottom, like bases again. Okay, so it's telling you subtract the like bases, because you could have more than one, base that you're talking about. So like bases, you subtract. So let's take a look. And we're going to see why this works. All right. So here's our rule. Okay, like bases, we're going to subtract the numbers from top to bottom. Here's an example. So if I have x to the 5th, x to the 2nd, that gives me x to the 3rd. Now, why does this work? Okay, because if you have 5 x's at the top, 2 x's at the bottom, when you cancel pairs out, like x over x is 1 whole, x over x is 1 whole, you're left with 3 at the top. Okay, so again, it's showing you why it works. Okay, sometimes when you can understand why it works, then you can really understand the rule, the property. All right, so here we go. So this is what we're doing over here. So we're just going to take these two numbers and subtract. You get x to the 5th. Okay, it's not a hard concept. You just simply subtract them. All right, for number 8, same thing. 13 minus 5, we have b to the 8th. Subtract the like bases. All right, number 9. Now keep in mind, we don't subtract these numbers, okay? So don't get that confused with these like bases over here. You actually divide with these, just like it's a division problem, like we normally do. Let's say we didn't even have these k's, and I gave you what is 27 divided by 9. You wouldn't subtract that, you would actually divide. So 27 divided by 9 is what? 3. and then you subtract your like bases. Okay, so please don't subtract these numbers here. Okay, that's only for the ones that have the exponents with like bases. Okay, if they're big numbers, then you either divide them, but let's say it doesn't divide evenly. Okay, so let's say you had 14 at the top, and let's say we had 16 at the bottom. Okay, so add this to your paper. So let's say we had that instead of something that could actually divide evenly. So if I gave you 14 over 16 and I said to reduce this, you would divide each one by what? By 2. And you do the same thing for this. So if it doesn't divide evenly and you can still reduce it, you would then say, okay, 2 goes into 14 7 times. Okay, write this down. And 2 goes into 16 8 times. And then you have the k to the 4th at the top. Okay, so it's not going to always divide nicely for you like this. Okay, just like in number 10. Let's look at number 10. So in number 10, now if this had been 30 at the top and 6 at the bottom, yes, I would have a nice number, but it's the 6s at the top, the 30s at the bottom. So that's really 1/5. Okay, it's not 5. If it was reversed, it would be 5. Okay, but 6 over 30 is actually 1/5. Okay, so we end up with this. Now, you don't need to write the 1 at the top when there's a variable there at the top, because technically we don't write 1 as a coefficient. Okay, but if the variable hadn't been there, we would definitely have to put 1/5. Okay, but since the variable is there, you leave the 1 out. Okay, all right, let's move on to number 11. So we can divide these evenly, so that'll give us 7. Then we subtract our f's. 8 minus 5 is 3. We subtract our g's. 6 minus 7. Now this is a little different here. 6 minus 7 is -1. Okay, because it came out negative, and we're going to give a whole lesson on this later, we put it in the bottom to make it positive. So once we go over what do you do with negative exponents, you actually put them in the denominator or take the reciprocal of them so they'll become positive. So this should go down here at the bottom. Okay, because really 6 minus 7 is -1. So we put it down at the bottom. All right, let's move on to number 12. Okay, how do we reduce 12 over 32? Okay, I'll wait. What can go into 12 and 32? Yes. Well, 2 can, but is there a larger number? Yes. 4 is larger. Okay, so you always want to try to get the largest number. So here we go. 4 goes into 12 3 times. 4 goes into 32 8. Okay, then we subtract our C's. 5. Subtract our D's. Okay, actually, I think this is supposed to be a D, and that will give us 3. Okay. All right, so that's the rule for the product property and the quotient property. So they're just the opposite of one. So for product, you're adding. For quotient, you're subtracting. So let's go to page 1. Okay, so this is what you're going to do for your classwork. I'm going to do a couple of these with you. Okay, and then your homework is on pages 2 and 3, right? So for page 1, and again, we're going to apply the product property and then down here you're applying the quotient property. So let's see how we can do here. All right, so we're going to multiply these numbers on the outside. So we can say 2 times -4 is -8. 8 times -8 times 2 is what? Negative what? -16. So we're going to add our m's. We have an m here to the first, and then here to the first, and then we have m to the third. So how many m's do we have? So that'll be m to the 5th. Okay, 3, 4, 5. So over here, we're going to multiply this and get -6. That's an a to the first times an a to the second. We add them together, we get an a to the third. Okay. So again, you're multiplying those big numbers. You're taking like bases and adding them together. All right, I'm going to do a couple of division ones. So let's take a look at number 7. Now, I cannot reduce -3 over 2. You can't reduce that any further. So just leave it as -3/2. Now, when I subtract, I got 1 minus 2. Well, what is 1 minus 2? Negative what? -1. So we're going to put it down here because it's -1. Okay, so it'll become positive. All right, let's look at number 8. Now, 2 divided by -2 is really -1. So I'm just going to put a negative right now because unless there's nothing at the top, then I will write the 1. It is going to be something at the top because what is 4 minus 1 at the bottom? 3. Okay, so again, you're subtracting those exponents when it's division. Okay, let's look at number 9. So 4/3 I cannot reduce. Now I don't have any other x's at the top to subtract this x to the third with, so it's going to stay there. I don't have any x's at the top. Okay, I do have a y at the top, 4, and a y at the bottom, which is 2. So what is 4 minus 2? 2, and that goes there. Okay. All right, I'm going to do one more. Okay, the 2 will stay. I don't have anything to reduce it with. Subtract my x's. 3 minus 2 is 1. And I don't have any more y's, so the y to the third will stay where it is. Okay. So right now, just keep in mind, if you subtract it as negative, just put that in the denominator, because by doing that, it becomes, we get a positive exponent. And we'll do that rule next class. Okay, but for right now, if you subtract and it's a negative, just place it in the denominator. All right, any questions?